Okay, so we're going to take a look at our imaginary numbers, and this is 5.5 here this year. And what we're going to look at is kind of exactly does an imaginary number mean? It's a very, very bizarre term. The fact that they're using the term imaginary is really causing a mental block for a lot of math students. And it's actually a really simple concept. So what happened was a long time ago, they were trying to solve this problem, x squared plus 1 equals 0. If I subtracted 1, x squared equals negative 1. And what was happening here, we were taking the square root to solve this, the square root, so we would say x equals plus or minus the square root of negative 1. And mathematics kind of stopped here for a long time. And one day, a couple people kind of just decided that, hey, what happens if this actually does work? What if this is actually a number? And let's make this number I. So the square root of negative 1 is I, and also you need to understand that I squared is the square root of negative 1 times the square root of negative 1, which is negative 1. So these are two important things that you've kind of need to grasp when we're doing when we're working with imaginary numbers. And what's interesting about imaginary numbers is they fall into a pattern, as you can see from this table right here. Okay, what happens here is if I know that I is the square root of negative 1 and that I squared is going to be negative 1, I to the third power is really just I squared times I to the first. So that's really negative 1 times I, which is really negative I. And then if I try I to the fourth power, that's really I squared times I squared. And then I'm going to get negative 1 times negative 1, which is really just 1. So you can see it's a little bit easier up here in the table. But if we look at the table right here, it's just going to keep repeating. I've got I squared, I to the third, I to the fourth, and now I to the fifth is really just I. I to the sixth is really just negative 1. I to the seventh is really just negative I. And then I to the eighth is 1. And it'll just repeat, repeat, and repeat. Okay? So first, let's figure out how to convert to I, right? We have the square root of negative 2. So what I'm going to do here is pull this out into the square root of negative 1 times the square root of 2. What is the square root of negative 1? We now know that that's I. What do we know here? The square root of negative 4. Well, that's the square root of negative 1 times the square root of 4. The square root of negative 1 is I. The square root of 4 is 2, so I'd say 2I. Square root of negative 121. I'm going to write the perfect square first this time, and then the square root of negative 1. So the square root of 121 is 11, and then I. Okay, so it's actually pretty simple here. The square root of 100 times the square root of negative 1. Square root of 100 is 10. Square root of negative 1 is I. Okay, the square root of 196, I'm going to pull this out and then pull this out. So the square root of 196 is 14. The square root of negative 1 is I. Okay? Now these get a little bit more complex, right? Because now here I'm going to separate this into three things. First, the square root of negative 1. And then what perfect square goes into 24? 4 and then 6. And of course, how do I find that? How do I find 4 and then 6 here? All right, if I go over here, clear this out, I go 24 divided by x. And then here I can look for, in the table, I can look for perfect squares. And there it is, 4 and 6. Okay? Now, what is the square root of negative 1? I. What is the square root of 4? 2. What is the square root of 6? Can't break that down any farther. All right, so that's just going to remain the square root of 6. Now, the order you should write this in is 2i radical 6. okay? So now let's look at the square root of negative 80. All right, I'm gonna break it into three things. I'm gonna get the negative out of there, and then I'm gonna find my perfect square that goes into 80. Okay, so if I wanna go take a look at that, let's go back here and kind of find out. I've got 80 divided by x to find our factors here. Let's check out the table. And now 4 and 20 work, right? Because 4 is a perfect square, but you wanna find out the highest one. And here, 16 and 5 is a value that 6 and 16 is a perfect square. All right, we're going to use that. All right, so I've got square root of 16 times the square root of 5. I'm just pulling apart that number. So now I've got I've got 4, and I've got radical 5. And then write it 4i radical 5. Okay? One more practice, the square root of negative 162. All right, so we're getting numbers that are a little bit higher, but just follow the same method. 162 divided by x. Go to your table, and then look for perfect squares, okay? So I've got 9 and 18, so that's a good one. Let's see if we can go a little bit higher here. All right, and what you can, oh wait, I think I missed it in the beginning. Right in the beginning here, 81. Now that's the highest perfect square that goes into 162. Okay, so I'm going to separate this into three things, right? The square root of negative 1, I've got the square root of 81, and then the square root of 2. So this becomes this becomes a 9, this becomes the square root of 2, and then write it 9i radical 2. Okay, so that's how you convert into i's. Okay, and the last thing we want to look at is what happens when we do have powers of I, which is going to bring us back to this table up here. So if I ask you what is I to the 25th power, if you notice here, there are 1, 2, 3, 4 columns, right? So what I can do here is if I divide 25 by 4, okay, and what am I going to get here? I'm going to get 25. I'm going to quit out of here. 25. I'm going to divide by 4, and I'm going to get 6.25. Right. So really, the remainder is 1/4, 6.25. Right. So what that means is this is really I to the first power, which is really just I. Okay. Now, where did that 1 come from? 1 is represented. The first column right here is represented by 0. Like if we have a 0 as a remainder. The second column here, the first column here is represented by 0.25, like I to the first power, right? There's 1/4 is one way to think about it, right? So 0.25 is 1/4. The second column here is 0.50, which is 2/4. The third column here is 0.75, which you can think about as 3/4, or I to the third power. And then the fourth is really if you have a remainder of 0. Okay, this could get a little bit confusing, so it's best to really just practice or use your table to help you kind of memorize. But really, it just works in cycles of 4. Okay, all right, I hope this helps. Have a positive day.